For this video, we're going to look at another couple of quadratic type questions. And again, what I'm focusing on with these videos here is recognizing patterns and ways to make the problem more simple than its complicated version. Okay, so look at this for a minute. In the equation, ax squared plus bx plus 9 is equal to 0, they say a and b are non-zero numbers, okay? And it says the equation has exactly one solution, which of the following expresses a in terms of b. Well, let's parse this for a moment. If we have one solution to a quadratic equation, that means we have something like this, right? We have like x plus 2 times x plus 2, right? Because in that case, for both of these, if we had these factored out, that would mean the only value for x that would make it work would be -2. Okay, so we have something like that here. Okay, and the only clue that we're really given is that we have a 9 in there. But then we have these other variables a and b. Now, this could drive people a little bit nuts trying to factor this out and figure out what would a be in terms of b and try to solve for this, but let's keep this really simple. Let's pick some numbers. Again, this is a completely acceptable SAT strategy, and I want to start with a for a moment. The easiest number to pick for a in order to kind of factor this thing out and solve it would be, let's say a is equal to 1. Okay, just bear with me for a moment. So if a is equal to 1, that whole equation becomes x squared plus some unknown bx plus 9, and that's supposed to be equal to 0. Now, theoretically, b could be anything we wanted, right? But they say it has only one solution. So hopefully this should somewhat ring a bell, right? We would need two numbers such that they would multiply out to 9, add up to make this b, but we want these numbers to be identical to each other, and that would hopefully, everybody follows this, that would have to be 6. It should be x squared plus 6x plus 9 is equal to 0, because if you factor that out, that gets us to x plus 3 times x plus 3 is equal to 0. So that means we only have one solution. The only answer to this would be x has to be equal to -3, right? So what we have, let's just back up for a second. What we have here is if we picked an easy starting value for a, it's easier to factor a quadratic when your leading coefficient is just 1, then that would have to mean if a is equal to 1, then b would have to be equal to 6, right? And that would give us just one solution for x. Well, then we can take this and check each one of these answer choices and see if we plug these things in, that actually works. Well, look at the first one. If a is 1, we have 1 is equal to 6 over 2. Clearly that's out, right? Because 6 divided by 2 is 3. They're not equal. Scratch that one. Same thing here. 1 is equal to 6 divided by 3. That's 1 is equal to 2. That's not right. 1 is equal to 36 divided by 4. That's not right. And so on and so forth. That one's also wrong. And that gets us to, let's see, E. Well, process of elimination has to be this one, but let's double check it. B squared is 36 divided by 36 is in fact equal to 1. So there's our answer choice. That's all we have to do. Again, the idea here is recognize patterns and keep the equation simple. And sometimes the easiest way to do that is just pick some initial values for the variables that you're given and then just test them with your answer choices. Okay, so enough on that one. Let's do this one. This is very similar to the problem that we did in the previous video. So I'm going to zip over it very quickly. But look at this. We have, again, weird fractions here for m and weird fractions here for n. But they're asking us what is m squared minus n squared. Okay, again, the trap would be to try to square this whole thing, square that whole thing, and subtract the 2. But we can recognize a pattern. We know that when we have something squared minus something else squared, that can be abbreviated like so. That's the same thing as m minus n times m plus n. Again, difference of two squares theorem is what this is about. So that makes it relatively easy, right? So that would just be subtracting these two things. I might just leave this as an exercise for the viewer here. I think from here it should be pretty easy to do. The big takeaway is just recognizing that we can subtract these two terms. Anybody who gets stuck on this, can't figure this out. Sorry, I'm babbling. Wait, let me just back up for a moment. The big idea here was recognizing that m squared minus n squared could be rewritten as such. And so then all we have to do is just subtract and add those different terms together. Probably some stuff is going to cancel off, and then just multiply. So I'll leave that as an exercise. Let's do one last one here. Okay, so it says 174. So if we have A is equal to this thing, and B is equal to that thing, they say, what is A in terms of B? So essentially, we're just asking, so we have A is equal to something, 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 where when they say in terms of B, what that means is that the only variable we want in the squiggly portion is B. But in the original writing, we have an X in there. So basically, we're going to have to somehow swap in a B for that X squared. Well, our second equation is giving us B in terms of X. So here's what I can do. I could say, look at this. If we want to swap this out, we can say B is equal to 7 plus 3x. Well, I could do a little rewriting. I could say that's the same thing as B minus 7 is equal to 3x, which then, a little bit further, B minus 7 divided by 3 is equal to x. Okay? So we found a replacement for x. Instead of writing an x, we can write something else that has a b in it, which fits what our conditions are. So let's just do that. If I plug that in, that gives us to a is equal to 6 plus 9 times whatever x is squared. Well, we rewrote x as the same thing as b minus 7 over 3, so let's just plug that in. B minus 7 over 3, and all of that is squared. Okay, so now this gets a little irritating, but we can do this. B minus 7 squared is going to be what? That's going to be b squared minus 14b plus 49, if I'm not mistaken. Double check me. I was foiling it. But then 3 squared is going to be 9, so that's just divided by 9. But all of that was supposed to be multiplied by 9, right? So here, let me just clean this up a little bit. Here's what we have. We have a is equal to 6 plus 9 times all of this. B squared minus 14b plus 49 divided by 9. There we go. Okay, almost done. So we can see here that the 9s are going to cancel off, right? If I multiply this entire thing by 9, but then I'm dividing it by 9, we can just scratch those off, and we're just left with, switch up colors again, we're left with a is equal to 6 plus everything inside here, plus b squared minus 14b plus 49. Okay, and then let's see, what terms could we combine together? It looks like the 6 and the 49 could go together. We could add those together. That makes 55. So our final answer should be a is the same thing as b squared minus 14b plus 55, which gets us to answer choice D. Hopefully this was helpful.